So the talk is titled. It's hacky, but at the same time, it works. It's pretty interesting. Uh, I will get into what exactly multi-platform means here, but it's not just multi-platform, but how we wrote SDKs for multiple platforms and multiple frameworks in React Native. To give you like some background info, just a second. Yeah. My name is Palash. I'm the co-founder of Diet, and I also have been leading the front-end division of it, writing SDKs. I've previously worked in Android security at CloudSec. Um, in this talk, like this particular SDK was also developed by Rohit Bhatia. He doesn't work at Diet anymore. He's working on his own startup, but I had to mention him as well. So, to continue further, I first have to talk about the backstory of Diet because you need to have some context to understand why we made the decisions we made. So, Diet initially in November 2020, we started building a Zoom competitor. We got into Y Combinator and we were building a consumer app. Midway through Y Combinator, we realized that we could switch to the video SDK domain. And in March, we pivoted to developing video SDKs. To give you more context, basically we were competing against Agora, Twilio, and allowing people to embed real-time live audio video in their own apps. So March is when we pivoted, and in May we released our first web SDKs, uh, and this is how our web SDKs looked. It's basically a one React component. You import that component and you get this entire meeting UI, a Zoom-like meeting UI. And of course, it's in your own app. It's a React component. You can customize it to look like your own app, to match your own use case, everything from like colors to like branding and theme. You can also customize it further using like the JS API. So we provided a JS API to like basically get all the meeting data, take actions on it. If I want to like mute myself, unmute. So we provided a JS API to take all these actions programmatically, listen for changes on data. So that is what we were till June 21. And of course, our pivot to SDK was showing to be successful. And so we wanted to now develop mobile SDKs. The only problem was that our total engineering team size was about 7 at that time. And while 7 might not sound like a too low a number, but in context of a WebRTC company, you have uh, obviously the front end SDKs, you have the actual WebRTC media layer, you have your SRE DevOps, and you have your backend. So, and us being an SDK, we could not provide uh, a video SDK that only works in one platform or in one framework. So we had to support React Native, Flutter, Android, like native Android, iOS, because our customers' app might be written in those frameworks or platforms. Uh, so with a limited engineering size, limited engineering team, and us wanting to develop these SDKs, it wasn't plausible to like make 4 different SDKs. So we went with a very radical and a very different approach. What we thought, what if we could have one common code base that is powering our React Native SDK, Android, iOS, and even Flutter SDKs. More on this later. I know this could be confusing, but I can guarantee it's very interesting on how we basically. I'll walk you through how we developed each of those SDKs and the problems that we face developing each of these SDKs. But all of them are written in React Native. So step one was porting the React code to React Native. We already had a React based web SDK. Now we wanted to port it to React Native SDK. So couple of challenges here. First, I'll talk about native modules. I know Aditya's talked like an hour ago, dealt with this subject, but I'll basically talk about native modules from another perspective. So when you are developing a React Native application, you are using the JS API and the APIs that are provided by the React Native system. But sometimes you need to do stuff that is not provided by these API, and so you have to write actual native code. So the native modules in React Native allow you to do specifically that. And talking about Diet, why do we need native code? We need native code to handle audio playback, like if you have a Bluetooth connected, switching to that, handling permissions, and etc. This is just a couple of examples that I'm giving you. But to build an audio video SDK, you'd need a lot of native code. So the problems, first I'll just explain how they work. To give you an example, we want to keep like the mobile screen awake. If you are in a meeting, if you are in a video call, you don't want your screen timeout to shut down your display. You want your screen to be open all the time. So how do you do it? You basically make a native module. And how do you make a native module? This is just an Android example. I'll also talk about iOS. But you make a module class, and that basically extends React context-based Java module. And in that class, you define your methods. So here, if as you can see, I'm defining a method called activate screen wake, and I'm annotating it with React method. What basically all this magic gives you is that now from JS, I can call this function diet helper.activate screen wake, and this will actually call the native part of it. So I can write all the native functionality I want, and call them from the JS API. So this is how I write them. But how does the third part actually work? How does the React Native how does it discovers my packages? While you're making a React app, your like the main application that you would have on Android would be an instance of like a React application. You'll link a React package to it, and this React package may contain different modules, and these modules will have React methods that you actually call. So this is how the linking is working. Like your application links to a React package, which links to modules. Now I understand that while most of you would not have developed these native modules on your own, you would have like installed third-party dependencies that would allow you to that would made you do npm run link. And so when you do that, that basically means that this particular dependency has a native code to it that you now need to link. So this is the Android side. On iOS side, you don't do any of this stuff. Like if you write a native module and if it's compiled into the code, it's discovered at runtime automatically. So now this is how linking is how you would write your own modules. But now, for example, if I install a third-party dependency, how does the native module from that third-party dependency gets linked to my code? How does the React Native auto-linking work? So basically, the React Native, when you install a project and you link it, you run npm run link. If it's an Android project, there are basically two Gradle plugins that will go to your node modules, see your dependencies, see the node modules, and basically link those Android projects to your main project. And another Gradle plugin will now link the React package from that third-party dependency to your main application, to your React application. So on Android, these two Gradle plugins basically help you discover third-party native code. I'll tell you why I'm talking about this in detail, because while you're developing an SDK, while you're developing a native module, you need to worry about a couple of things. On iOS, there's a similar script which basically, again, because you don't need to do the linking on iOS, discovery is automatically discovered at runtime. All you need to do is make sure that these modules, they are built when you build your own app. So there's a script which basically includes it in your build scripts to also compile those native modules. The problem is these two scripts, these Gradle plugins and these scripts, they will only auto link native code that is in your dependencies. But if we have some dependencies ourselves, the auto linker won't link those dependencies. Okay, so now when a client who installs your SDK, the auto linker will only link the native code that is existing in the Dite SDK package, but not link the native code that is there in our dependencies. So how do you solve this? There's no straightforward solution. You write as much native code in your own SDK. And second, for stuff that you can't write, you basically ask the clients to install them on their own base app. So for us specifically, we use React Native WebRTC, React Native WebView, vector icons. So we ask clients to install them install them on their base app. So these are linked, auto linked in their app building. So how does our SDK actually look? Basically, if you want to integrate a Dite SDK in your React Native app today, all you have to do is import this Dite module and basically this component, render this component. That's it. And you get the entire meeting UI and all the native code, etc. Everything else is handled by in its own. So now second part is now that we have a React Native SDK, our customers might also be using plain Java Kotlin apps or iOS Swift Objective-C apps. How do we give out our SDKs? How do we give out this React Native SDK to clients using not using React Native? So our goal, we have 3 goals here. Our SDK, our Android SDK or iOS SDK needs to return a view which will contain the entire UI. It needs to give out methods to control the meeting, like disable camera, enable camera. It needs to listen for changes. And basically, third thing is client need not be exposed to a lot of installation steps. It needs to be as seamless as if it were an actual native SDK. So for these 3 goals, for like goal 1, where we want to return a React meeting UI, what we do is if you have installed React Native, if you have bootstrapped your React, there are basically 2 ways to initialize React Native if you go on their official docs. One is for a fresh project, and the second approach is for a existing app, how to integrate React Native in your existing app. So using that pattern of initializing React Native, you can basically get a view that contains the entire React Native like meeting UI and return it back to the user. Now the second goal is how do you have clients call method on the Android iOS side and basically execute those events on the React Native side. So the way this works is you call a method, we emit a native event, which is listened by the React Native SDK. If there are any data changes, if there are any other events, React Native SDK will call a React method, the same React method from native modules. And when this is called, we basically do a local broadcast and these classes, the Dite meeting, Dite self, Dite participant, these classes listen to these events. So you call a method, it sends a native event, it is listened by the React Native SDK. Any changes in the React Native SDK, it lets the native side know by using React method and a local broadcast. On iOS side, we do almost the same thing. It's just instead of a local broadcast, we update a shared instance. So now what we have achieved so far is we are able to give clients a view back that contains the entire UI, and we are able to expose methods and data members to see what is happening in the meeting and take actions on it. So like this is how it looks. This is how the entire packaging looks. The third part is, of course, how to package everything seamlessly so that the fact that it's running React Native is not even evident to the client. Client is only exposed to the outer surface. So basically what you have to do is, of course, you have to package your bundle. You have to package React Native Engine, JSC core. You also have to package the native code required by other dependencies. React Native WebRTC, React Native Vector Icons, WebView. And you need to package all of this seamlessly. On iOS side, you don't need to like package JSC core, it's already there. But the point that I'm trying to make is that this whole packaging needs to be very, very seamless, that the client is, it's a single line installation at the client's end. So the way we basically, most of it is straightforward, except the second part, where how do you package React Native WebView in your Android project. So what we do is we basically, for all these projects, we build AARs. And once these are built, we basically include them in our Maven dependency. Now, because these are not these projects, they are only installed through NPM or Yarn. So they're not there, they don't exist on any Maven or any central repository. So we basically package all of these, and we also put them on the like a public Maven. And in when we publish our SDK, we basically include all of them as dependencies, Maven dependencies. So how does it look? How does it look to the actual client? So for a client who's just using Java Kotlin and wants to integrate our SDK, you basically put our package name in the dependencies. And if you see how it's actually used, you set, again, a couple of parameters that are required by our SDK, and you call dietmeeting.init with like the width and height, and you get a like an Android view back that contains the entire React Native UI. So as you could see from this packaging, it's very seamless. You one line installation, couple of lines of installation, and we are basically able to package all of this very seamlessly. Of course, I during like this talk is I can't cover in depth on how we did this packaging, but there was a lot of gluing required here and there. As you would assume that, as you would understand, this is not like a very straightforward approach. So at the end, but we get this, a very seamless experience for our clients. Same for iOS. You put a pod and you get a, like, if you could see the usage example, it's a view controller, and you can use our view controller and initialize the meeting there. Again, very simple, very Android iOS like. You wouldn't even know if it's an React Native SDK. So step 2 is complete, and we have our Android and iOS SDKs. We also have React Native SDK. Now the third step is very interesting. Our clients might be using Flutter apps. And so how do we ship a SDK that was built in React Native to someone using Flutter? And we basically do a wrapper on a wrapper. So the inner box is our Android and iOS wrappers. And so if you are aware of how Flutter, like if people here understand how Flutter works, Flutter also gives you two primitives. One is a platform view and method channels. So platform views, what they do is platform views in Flutter, they allow you to integrate native views in your own application. And method channels let you communicate with native code. It's the same thing as native modules, how in React Native world, they let you communicate with the native code. Similarly, in Flutter's world, method channels let you communicate with. So every time there's a event that originates in the React Native SDK. We call a React method, send it to the outer layer. Uh, this basically updates a shared instance or causes like a local broadcast, and then using method channels sends it to the Flutter side. Again, I know what you're thinking. Yeah, for why do this? Why do this at all? At the same time, this is also like very cool. How do you manage to do this? Uh, Couple of memes here. So, how does it look to an end user who's installing our Flutter SDK? You put a diet widget and you call the room name or token, and that's it. The client, it's so seamlessly packaged that you get like a very Flutter like experience integrating a React Native SDK. Again, I would like to reiterate the constraints that I originally said in the beginning of the talk as to why did we do this. We had like an engineering team of 7 people, could not manage to build 4 different SDKs. So yeah, here it is how we've developed 4 different SDKs and used just one common code base. So what were our learnings from this? Why would I not do this again if I was asked to? First of all, being a audio video SDK provider, uh, we had a very coupled UI because, of course, your clients are using it in Flutter, and while your UI is written in React Native, of course, there is no going to be no customization. Uh, so no customization, and second, performance issues. So while there were no performance issues in like the iOS and the uh, Android wrappers, of course, there was some like how React Native performance versus native performance. That's another debate. But because our meeting UI specifically, there was not a lot of movement or interactivity. It's just that you get video streams and you speak and you listen to audio. So not a lot of no, in fact, not even a lot of, but no significant performance impact in our core audio video experience using the Android iOS wrappers. In Flutter specifically, there was some uh, performance impact, especially like less than Android 10. If I'm just like quoting a doc from the official Flutter docs, quoting a. So if you could read this, while a platform view is rendered with hybrid composition, the Flutter UI is composed on the platform thread. So you are basically, it doesn't run on the same thread and slows down the entire UI. It's not actually bad, but some performance degradation is visible. The third thing is, of course, the SDK size. And because now you're technically including React native code, like the native libraries, and those libraries are written in basically they are compiled per architecture. So you'll have 4 sets of libraries. So every time we give out a Flutter SDK, it basically adds a 56 MB to client's production build. And most of it is React Native. So React Native, as far as I remember, takes like about 8 MB per architecture. So and the rest of it is the actual WebRTC builds. So lib WebRTC, the client the client library handling the WebRTC part of it, which is used by like every single video calling application, adds another 5 6 MB. But which even if you had a native SDK, you would have. But here you are including those native React Native and JSC core libraries, uh, and that is increasing the production size. But because these are per architecture, the customer actually just sees a 15 MB increase on Play Store, which while if you want to reduce is not the worst thing in the world. But because all of these are per architecture, the client sees a 50 60 MB build, and basically it's not a pretty sight seeing installing an SDK and it increasing 60 MB to your client's app. So yeah, would not do this again. but at the same time, the whole experience made us understand React Native, Flutter, from depth to depths like we would not usually be exposed to. So from a learning point of view, it was good. And again, reiterating the constraints we had, this was the best possible way. So how are we with the problems that I mentioned? We basically, in like the later stages of a rewrite, we are releasing 100% native SDKs next month, and these SDKs, at least the non UI part of it, is written in Kotlin multi-platform. Another very interesting technology. Uh, so yeah, and of course now we want UI customization as well. So we are releasing UI kit for React Native, Flutter, Android, and iOS. Releasing next month. Reach out us for a beta, and yeah. Also, we are hiring across all positions, specifically React Native. You'll not work on this monstrosity. You'll work on the newer SDKs. So please apply if you're interested.